Good day guys, welcome back to another amazing session on Wikiscience Studios. In this video, I'll put you guys through Iupac nomenclature of organic compounds. So we'll look at the established rules in order to name very well the organic compounds in different ways which they can be presented to you. So let's get started. Now look at these established rules which are enlisted here. The first one is that the longest carbon chain is considered in an organic compound. So let me just give you an organic compound to name so that we can use these established rules to name the organic compound. I'll give you something like this. When you are presented with something like this, there's tendency that you might miss the Iupac name of this compound. Why? Because there are some things which you must consider before naming. The first one is that the longest carbon chain is considered. Now, if I should go in this manner now, I'll count the number of carbon which I have. 1, 2, 3, 4. So I have 4 carbons on this straight chain. On this straight chain, I have 4 carbons. However, is this the only direction which I can move to identify the carbons? No. I can also come down from this particular carbon here and go in this straight manner. From here, we have 2 carbons here already, and this one becomes 3rd carbon, 4th carbon, and this is the 5th carbon. If I should go ordinarily here, I have 4 carbons. If I should go from this particular ethyl, it will give me 5 carbons. So which one should I consider? Definitely, I will consider the longest chain. That is the highest number of carbon, which is 5. So it means that I will never go in this way. I will never go in this way. I will consider this particular one in which the longest number of carbon is considered. So now, let me quickly withdraw this. So I'm starting from this ethyl here, which is C. We have 2 C, or we have 5 H. Let me quickly distribute the H. 1, 2, 3, 4, and we have 5 to be here. After that, we have the next carbon here. On this next carbon, we have a carbon behind it. And the carbon behind it is taking 3 hydrogen, 3 different atoms of hydrogen. So let me just put that up here, CH3 here. So this CH3 is identified to be up here. And the other hydrogen connected to this carbon, the other hydrogen will be taken down. Now let's move to the next carbon. The next carbon now will be C, and you have what? You have your bromine to be up, and you have your hydrogen to be down. And the next one will give me C, I have my bromine to be up, I have hydrogen to be down, and I have my H. So I've withdrawn this particular chain in the manner of the longest carbon chain. Now the next rule states that identify the substituent. Now what do we mean by identify the substituent? The meaning of this is that the carbon atom which is not included in the chain, will be used as a substituent. That is, it is not taken as a member of that chain anymore. So here now we have this particular carbon. This particular carbon here was not included in the chain, so it is taken as a substituent. So this is a substituent now where you have to be CH3. It's taken as a substituent. Another substituent which you need to determine here is that when the atom attached to carbon is not hydrogen, it is also a substituent. So this bromine is not hydrogen, it's attached to this carbon, so it's a substituent. This bromine here is also attached to carbon, it's not hydrogen, so it is a substituent. So we have 3 substituents identified here. The first one is methyl, the second one is bromine, the third one is also bromine. Now let's look at the second rule. The second rule states that determine the position of the substituent. When you have to determine the position of the substituent, it means that you have to number the length of your chain. And in order to number the length of your chain, you either go forward or you go backward. You can number the length of your chain forward or backward. Now let's go forward. 1, 2, 3, 4, 5. You can also number backward. We have it to be 1, 2, 3, 4, 5. When I number in this way, you realize that this methyl group here is taking position of 3, the bromine here is taking position of 4, the bromine here is taking position of 5. However, if I'm going back in this backward manner, the methyl here will be taking a position of 3, bromine here will be taking a position of 2, and the bromine here will also be taking a position of 1. So which one is lesser? 1, 2, 3 is lesser than 3, 4, 5, isn't it? So in that case now, we will rule out the forward numbering. So now let's take this backward numbering, because this backward numbering gives the substituent a lesser value. So now the next rule states that number the chain in a way substituent take lesser number position. substituents take lesser number position. So in this case now, the substituents are taking lesser number position. Bromine is taking position 1, bromine is taking position 2, and methyl is taking position 3. It's taking a lesser number position. The next one states that substituent is named alphabetically. Now this is a substituent, this is a substituent, and this is also a substituent. Alphabetically in this case is that the closest alphabet is named first. So here we have bromine as a substituent, and here we have methyl as a substituent. You realize that the first letter here is B, the first letter here is N. So here we have it that bromine will be named first before we name methyl. Bromine will be named before methyl. So we take bromine first. Now in this case now we also have identifying the position of bromine now. You realize that bromine occur on position 1 and it as well occur on position 2. So the occurrence of bromine is twice on position 1 and on position 2, and as a result of that, the reoccurrence of this, since it's 2 times, will be taking di according to the rule here. If it is 3 times, it will be tri. But for methyl is occurring at 1 position. You don't need to include this because it's not reoccurring. So we just have the position to be identified, which is position 3. Now the next 2 state that the substituents are named before the chain name. The substituents are named before the chain name. So let's name the substituents here. So now we name this to be 1, 2. We use comma to separate numbers. They will have hyphen to separate numbers from letters. We include di here because the bromine is occurring twice. We call it di-bromo. And what do you have? Comma to separate it from the other substituent, which is methyl, 3-methyl. Now to determine the name of the chain length, the name of the chain length is dependent on the bond that is present in the chain length. If it is single bond, it is called alkane. If it is double bond, it is called alkene. If it is triple bond, it is called alkyne. But if this particular chain length is carrying another functional group, as in case of OH, which is alkanol, in case of COOH, in which is called alkanoic acid, or in case of CHO, as in case of aldehyde, or CO, as in case of alkanol, then it means that the name of the chain will be dependent on this functional group. But looking carefully at this now, there is no functional group here aside from alkane, which is a single bond that is present in this chain length. So we call this alkane. So this particular chain length now is of alkane. Since it's of alkane, we look at the number of carbon present. The number of carbon present here is 5. And in the series of alkane, when you have 1 carbon, it is called met. When you have 2 carbon, it is called et. When you have 3 carbon, it's called prop. When you have 4 carbon, it is called but. When you have 5 carbon, it is called pent. So in this case now, we call it pentane because it belongs to the alkane. So we call it pentane. So this is 1,2-dibromo 3-methyl-pentane. So this is the name, Iupac name of this particular structure given here. Many of you will have named it in such a way that you can say 1,2-dibromo 3-ethyl, in which this particular ethyl is taken already now as a component of the chain length. Why? Because it makes the chain length to become longer. That's the reason we've included it in the chain length and not consider this C2H5 as a substituent. Now we're going to give you another example now so that we'll be able to understand it more better. Let's take another example with respect to this. Now let's take another example in which you have something like this. I've told you earlier that you consider the longest carbon chain. Now when you go straight down like this, realize that we have 1, 2, 3, 4 carbon. But when you look carefully into this particular structure very well, you can still go straight down like this and come down like this. You have to be 1, 2, 3, 4. So you still have 4. So this results into 4, this results into 4. However, what if you move from this propyl that is here up? When you move up and you go straight forward, realize that this is 3 and this becomes 4, 5, 6, 7. So in this case now, you have your direction like this to be the longest. So this one is producing 7. However, you can still move straight up, forward and downward like this. It will still give you 7. So you have 3, 4, 5, 6, 7. It will still give you 7. So it's rather better you just go upward and straight down. So in this case now, let's redraw this chain. when you want to read just this chain length, we have what first? We have C3H7. So let's quickly draw this C3. 1, 2, 3. This is C3. We have 7 hydrogen. 1, 2, 3, 4, 5, 6, 7. And now we have the next carbon. So let's draw the next carbon. On this next carbon, we have two things: chlorine atom, hydrogen atom. So we have chlorine atom, we also have hydrogen atom. We have the next atom, carbon atom. To the next carbon atom, we also have chlorine atom and hydrogen atom. To the next one, we have chlorine atom, and we have methyl, CH3. To the next carbon atom, we have it to be C, and we have your hydrogen, and we have hydrogen, and we have hydrogen. So here we have hydrogen this way. Now in this case now, you realize that the next true state that we should identify our substituent. So identifying the substituent, we have chlorine here, as well as fluorine here. So we also have methyl here. So these are the substituents that we have in this particular structure. So here now we have the occurrence of chlorine. So we have to be chlorine, and chlorine is occurring 3 times. We have 3 times of chlorine, and that will take 3 times of chlorine. And we have methyl. Methyl is occurring once. And we'll take it to be ordinarily methyl. But when you look at this now, we want to talk about the numbering. Don't forget, the numbering is in such a way that the substituent will take a lesser value. So we can number forward and we can number backward. Let's number forward. 1, 2, 3, 4, 5, 6, 7. In this case now, it will be taking number of 4, 5, 6. Now let's compare with 1, 2, 3, 4, 5, 6, 7. Definitely, you realize that 1, 2, 3, 4, they are the lesser number value which you can number this particular structure or chain length. So rather better we take away these ones, because it's going to give us higher value of naming. That's 4, 5, 6. And we don't want to go in that direction. You must take a lesser value, which is 1, 2, 3, 4. So now this is the correct direction of naming, to such a way that it gives lesser value. So here we have chlorine to be occurring 3 times, but the position of the chlorine include position 2, 3, and position 4. But for methyl now, position 2 is where you have your methyl. So you take note that you number your substituent first before you number the chain length, the name of the chain length. So here we have it to be 2, 3, 4, and what do you have? Tri, chloro. And what do you have? You have it to be 2 methyl, and you have it to be. Now the chain length, because this is also an alkane chain. This is alkane chain. Only single bonds are present. Then what do you call it? We have 7 carbon atoms here. In 7 carbon atoms, for 6 it will be hexane. For 7 it is heptane. So here we have it to be heptane. So you have to be heptane. So this is the name: 2, 3, 4 trichloro 2 methyl heptane. This is the correct name of this particular structure presented here. Now let's take the last aspect here, whereby we might not consider alkane. We might just take note of something like alkene or alkyne, so that we'll be able to understand it very well with respect to the hydrocarbons. Let's consider this last example. In this case now, we take the same procedure. The longest carbon chain is considered. Nothing changes. So here you have 1, 2, 3. We can go straight down as usual, and that will give us 1, 2, 3, 4. And that's giving us 4 here, 4 carbon atoms. We can go straight down to this point and we go upward. When you go upward, it will be 1, 2, 3, and you have 4, 5. So in this case, it's going to produce 5 carbon. But when you go straight down and you come downward, you have to be 1, 2, 3, 4, 5, 6. So this is going to produce 6. So it means that which one is the longest carbon chain now? It means that going straight to this point and will come down is the longest carbon chain. So let's look at how this will be named now. We just have to redraw the structure. So we have the first one is C, and is having bromine as well as hydrogen. What do you have in front? Double bond. What do you have? C, and you have your H. The next one is carbon atom, and this carbon atom is having C2H5, which is this one up. And we also have this particular carbon to continue along with C3 now. So it's going to continue with C3. 1, 2, 3. But don't forget, if it continues with C3H7, which is 1, 2, 3, 4, 5, 6, we can as well have 7. You realize that there is still a carbon structure behind. This carbon structure behind will come here now, so we have to be C, I have A to be H3 because it's still concentrated on this carbon, CH3. So here we have to be CH3. Now let's look at this carefully now. How many carbon do we have in total? We have 6. 1, 2, 3, 4, 5, 6. Nothing changes. Identify your substituent. So this is a substituent. This is a substituent because it's no more part of the chain length now. It's already a substituent. This is not also considered to be part of the chain length. It's also a substituent. So here now, these are 3 substituents. So what are substituents we have? We have ethyl. We have ethyl. We have bromine. We have bromine. And we as well have methyl. We as well have methyl. But now let's determine the position. In contrary to the rule that has been stated here, that substituent is determined the way the chain length is numbered. In contrary to this, you always have it with respect to double bond or triple bond. The double bond or triple bond determines the direction in which the chain is numbered, meaning that the double bond or triple bond take lesser value. It takes lesser value. It can also be a functional group, like in case of OH, in case of CHO, in case of COOH. The functional group there will take the lesser value. So now let's number in such a way that the functional group will take a lesser value. Let's go in a forward and backward direction. 1, 2, 3, 4, 5, 6. Backward. 1, 2, 3, 4, 5, 6. Now you realize that in this case now, the carbon carrying this double bond here is taking position 6, carrying the double bond. However, with respect to the which I have given you, that the double bond or triple bond must have lesser value. If it's even a functional group, it must take a lesser value. So in this case now, since 1 is a lesser value compared to 6, I'll cancel out or rule out this direction of naming. So it means I'm going to name forward. So here, the position of your double bond here now is on number 1. So bromine is said to have the position to be on number 1, while your ethyl is having its position to be on number 3, and your methyl is also on position 3. Don't forget what we said earlier, that substituent and name first. In alphabetical order, we have it to be 1. We have it to be 1 bromo, comma. The next one is 3 ethyl, and the next one there is 3 methyl, and after that, now let's consider the name of the chain. What is the name of this chain? Don't forget we have double bond here. So this is not alkane. This is alkene. So now for alkene, how many carbon do we have? 1, 2, 3, 4, 5, 6. After that, when you have 6 carbon, it is called hex. It is called X. But because this is alkene now, it will be hexene. So this is hexene. This is called hexene. When you name like this, it is not acceptable. Why? Because we expect you now to separate the prefix from the suffix of this chain name. You separate the prefix from the suffix of the chain name. When does this occur? Whenever the number of carbon atom is more than 3. Whenever the number of carbon atom in alkene or alkyne is more than 3, you always separate the prefix of that name from the suffix. So the prefix is X and the suffix is in. So I've separated this out. Now, why do we separate it? We separate it in order to sandwich the position of that double bond. If it is the case of triple bond, it will be the position of that triple bond that will be in between them. The position where that double bond or triple bond occur will be between the prefix and the suffix. Now, the position of this double bond is on number 1 carbon atom, so it will be X1 in. So the correct name for this compound or for this structure is 1 bromo, 3 ethyl, 3 methyl, X1 in. So this is the Iupac name of the structure that has been given here. Now we've gone to the end of this video, and I believe so well that these particular rules have been so much helpful to you guys. Now I want you to share this video with your friends, and as well subscribe to the channel if you haven't. We'll see you next time. Thank you.